Okay, so now we're going to create a visual of our data, and we're going to do that with a box and whisker plot. And so in order to create a box and whisker plot, we need our 5 number summaries, okay? And we're going to do what we call a stacked box and whisker plot. Because we're comparing the males to the females in terms of number of contacts, we're going to use one number line, and we're going to put one group, we're going to put their box and whisker plot on top of the number line and the other group below it. So we can definitely see that comparison right there. And they're closer and they're not on different number lines. Okay. So we do need our 5 number summary for the males and females. So what I want to do is I'm going to create one long number line. So on this piece of paper, I'm going to turn it to the side so I can create a long number line. If I was doing this for my project, I would probably use a ruler, or I would use graph paper to make sure that my intervals are nice and spaced out. We're just kind of sketching here for these purposes, but you do want, for the project, you want it a little nicer, and graph paper works well for that, or a ruler where you're measuring things out. Okay, so if I look at my 5 number summary, my smallest number is the male's minimum, which is 28, and the largest number is the female's maximum, which is 121. So I need to number my number line from 28 to 121. Now I do not want to number by ones. That's going to take me forever. So something more along the lines would probably be 5s. Definitely not 10s. That's too squished together. For the data, again, you'd have to look at your own data and make that decision. Maybe getting by 1s would work. What you want to do is number by the lowest number that is feasible. So 1 is not feasible. Could I number by 2s? Yeah, maybe 3s, but 5s is what I'm going to go with here. That's not too compacted. So 10s is too compacted and it's not going to be too long. So I'm going to draw my number line and I'm going to number by 5s. Now, here's the other thing. I am going to start at 5. If I was numbering by 5s, I also don't have to start at 0. Okay, I could start at, now I'm going to, because my lowest number is 28. If my lowest number was 100, I'd probably start my number line lower, not quite at 0, because that would be too large. So I have 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. 105, 110, 115, 120, and 125. So I have 5 and 125. That'll get me from 0 to 121. Again, this is a real rough sketch. You can see I made some of my intervals too big. But if I was doing this on graph paper, I'd have a better idea. Now I am going to do the male's box and whisker plot on top. So I'm only going to look at the male's number. What I'm going to do is put a dot for each one of these numbers. So the male's minimum is 28. So I'm going to go to 28 on my number line and put a dot there. Okay, I should number all of these, but I'm not going to, but you should number all of them. Okay, so 28, 5, 10, 15, 20, 25. So I have 25 and 30. 28 is somewhere in between. So I'm kind of estimating I put a dot above 28 there, somewhere between 25 and 30. Kind of estimated it. Then my quartile 1 is 62. So my next number I'm going to put a dot above is 62. So 30, 40, 50, 60, 70. So I'm going to estimate 62 to be about there. So I put the dot above where 62 would be. Okay, and my next one is 79.5. So that's really close to 80, almost 80, just shy of it. So 79.5. And then 93 is my upper quartile. So that's halfway between about 90 and 95. So I put that dot there. And then finally, I'm going to put a dot above 100. That's my maximum. So I put a dot above each of the 5 number summaries. Now I need to create the box. So what you're going to do for the box is you're going to draw a line through your quartile 1 number and your quartile 2. So that's 62 and 93 for me. So I drew a line through those. Now I'm going to draw a box. I'm going to connect those 2 lines with a box. So there we go. So I made a box with my quartiles. and my median is somewhere in the middle. So now I'm going to draw a line through that median dot. So there you go. It looks like that. Now that's the box part of the box and whisker plot. Now we do the whiskers. So the whiskers are, I'm going to draw a line from the box to that minimum and to the maximum to make the whiskers. So there's my box and whisker plot. I can see how spread out my data is, and this box represents my interquartile range. Okay, now I want you to go ahead and I want you to do the female one on the bottom of this, and then we'll compare. Female box and whisker plot done. So this is what it should look like. Okay, the minimum was 38, quartile 1 was 87, median was 95, quartile 2 was 113, and then the maximum is 121. So if you look, you can tell just by looking at the box and whisker plot that the females tend to have more context. Their median is greater than the male's median. All of the quartiles, their maximum, their minimum, everything is greater. You can also, a box and whisker plot also shows us an outlier fairly well. The fact that this whisker is so far away from the box compared to the other tells us that 38 is an outlier from the rest of the data. The males have that too with 28, although it's not as much of an outlier because that whisker is not as long. Both sets of data have their median pretty close to the middle of our interquartile range, the middle of the box, which is pretty good. I have had situations where the lower quartile and median are the same exact number, and that just tells you your data is skewed a little more. This is probably pretty good data here. So that's what your stacked box and whisker plot looks like. So this is where your 4.0. So being able to do this packet, everything we've done up to this point would be your 3.0 level as long as it's done correctly. Your 4.0 level work would be being able to answer these types of questions about your data. Compare the box plots. Do you notice a difference in shape, center, or spread? You know, and that's where you would say the females have, both of them have an outlier, but the females seem to have more of one. The females, all of their data points, their quartile median, other quartile maximum, they're all greater than the males. Both of them are pretty close to the middle. The male's box is larger. That means their data is more spread out than the female data. The female data is clustered in this area. Okay, and so I would be able to say that. Number 10, it is important to have data integrity. For example, it is important that data be reported accurately and truthfully. Do you think that is the case here? Do you see any suspicious observations? I made these numbers up, so they're not technically accurate, but maybe you could say, yeah, I asked these people to their face, or they showed me their phones and how many contacts. You know, we've had issues with data integrity in the past where, especially if we're asking high schoolers, they just kind of guess because they really don't want to take part in our surveys. Maybe you have someone who had like 1,000 contacts and you go, that seems way out of line for the rest of them. You know, what might be an explanation for that? Well, we had that situation one year and the explanation was that they had their parents' old phone. And so all of their parents' contacts plus theirs were still in the phone, that kind of a situation. 11, can you think of any reason someone might make up a response or not be completely truthful in giving you their data? Maybe they just didn't feel like it. You know, I've had students do a project on number of Snapchat friends that you have. Well, Snapchat doesn't just give you a number. You have to sit there and count them. Well, if I have 300 Snapchats for your survey, I'm not going to sit there and count them. So they might give you more of an estimate than an exact number type of situation. 12, summarize the results. So at the end of the day, who has more contacts? Based on all of our data, okay, the females have more contacts. Their mean is larger. Their median is larger. Their mode, I lost my mode paper. Their mode is larger, one of their modes. Their quartiles, you can tell by looking at the box and whisker plots. In general, the females have, on average, in general, the median says they have more contacts than the males do. Okay. What have you learned from the data? That's what we learned. Okay. Suggest possible reasons. Why do we think? So did it match your prediction? What are the reasons that females have more contacts, especially in 7th grade? Again, one of those could be, well, females tend to save numbers where males don't. I know that's the case with my husband. He has phone numbers in his phone, but he doesn't actually save them and put a name to them. He just has the numbers memorized. So when he sees the number, he knows who it is. So it shows that he has fewer contacts than I do. Just that kind of a thing. And then, do you think a study of a similar program would yield similar results? So if we did the same thing with adult males and females, would we come to the same conclusion? Would our data show that those females tend to have more contacts than the males? Okay. And then why? And kind of go from there. If your project is already on adults, would you yield similar results if you did adults in a different state? Okay, you know, those kinds of things. So a lot there that you can do. That's 4.0 level thinking. Again, 4.0 level thinking deserves a 4.0 level response, but we just did this together. This is exactly what your project is going to be, or these exact same steps. Okay.